The icy blue planet Neptune has a lot in common with its gas giant neighbor, Uranus. Both are ice giants with similar colors and compositions. But Neptune has one distinct advantage over its neighbor, a moon that could make it an even more fearsome planet than it is today. Neptune's moon Triton is thought to have been captured long ago. But what if it was not just thought to be captured, but actually was in the process of being captured right now? Well, first off, we can say with a fair amount of certainty that this wouldn't happen. Not only because it would be very unlikely for such an event to occur, but also because we would have already noticed it. The capture of a large moon like Triton would not go unnoticed. There would be lots of astronomical news about it. However, let's pretend for a moment that this scenario was actually possible and explore what would happen if Neptune managed to capture Triton. Before we begin, be sure to subscribe so you don't miss out on future videos. Also, stick around until the end to learn about something amazing that's happening soon. Triton is strange among Neptune's known moons, which are named after various Greek deities associated with the god Poseidon, who is the Roman equivalent of the Greek god Neptune. Unlike the other moons, which appear to have formed from the accretion disk surrounding Neptune during its early years, Triton is intermediate in complexity. This suggests that instead of forming at the same time and place as Neptune, Triton came from elsewhere in the solar system and was later captured by the planet's gravity. In fact, Neptune and Triton are locked in a strange gravitational dance. Every 6 days or so, Triton lines up perfectly between the Earth and the Sun. As seen from Neptune, Triton passes in front of the Sun only twice a year, once in the northern hemisphere's summer and once in its winter. And this alignment only happens because Triton is so close to Neptune. It orbits just 12,000 miles from the planet's surface, way closer than any other major moon in the solar system. For comparison, Earth's moon is roughly 340 times farther away from us. So you can see how unusual this is. Because Triton is so close to Neptune, it heats up. In fact, it's 380 degrees Fahrenheit hotter at its night side than its day side. In addition, Neptune's gravity pulls on Triton, which causes the moon to heat up even more due to internal friction. Now, thanks to all this extra heat, nitrogen ice on Triton evaporates and forms an atmosphere. Scientists think that the atmosphere may consist mostly of nitrogen, with some methane, carbon monoxide, propane, hydrogen sulfide, and possibly oxygen, and these gases form thin clouds in Triton's sky. So what would happen if Triton were to escape Neptune's grasp and wander off into interstellar space? Well, for starters, Neptune would lose its most dense atmosphere. As Triton is much closer to Neptune than any other of its moons, it influences the planet's atmosphere more than the others. As a result, Triton pulls many atmospheric gases toward it. So if it were to leave, Neptune's atmosphere would become thinner. However, Neptune's atmosphere would still be denser than that of Uranus, for example. Neptune's winds would also slow down. Triton's gravity helps fuel some of Neptune's strongest winds, which can reach speeds of up to 900 miles per hour. The planet's magnetic field, which extends far beyond its atmosphere, reaches Triton and interacts with the moon's magnetic field. These interactions drive electric currents in Triton's upper atmosphere, creating a heat that adds to the greenhouse effect and warms the moon's surface. The energy also creates powerful winds on Triton and enhances Neptune's jet streams. So without Triton's influence, Neptune's winds would become much calmer. If Triton were to escape Neptune's gravitational pull, the planet's tilt wouldn't change much. Triton makes Neptune's orbit slightly more elliptical, and its tilt would be slightly different. Without Triton, Neptune's orbit would be almost circular, and its tilt would be about 30 degrees. That said, the planet's overall shape wouldn't really change much either. Neptune is mostly made of gases and liquids, and its shape is mostly determined by the balance between its gravitational self-attraction and the centrifugal force created by its rotation. Even if Triton were to leave, Neptune's shape would remain largely unchanged. However, there would be one notable change if Triton were to leave. Neptune's rings would disappear. Neptune has more than a dozen known rings. And while scientists have yet to determine exactly why they're there, they think that Triton plays a big role in maintaining them. Triton's gravity may keep the rings in their current state and prevent them from expanding or contracting. Other forces, such as the tidal action of Neptune's gravity and the Coriolis force, which is caused by the planet's rotation, may also help maintain the rings. But without Triton's gravitational influence, the rings would likely collapse and expand, covering much of Neptune's surface. But what if Triton didn't escape Neptune's gravitational pull? What if instead it crashed into the planet? Such an event would be truly cataclysmic and would certainly cause a lot of damage. First, the impact would release a tremendous amount of energy. The energy would be released in the form of heat, light, and sound waves, which would shake Neptune to its core. The heat would melt rock and ice on both bodies, while the sound waves would travel around the planet at the speed of sound, causing massive earthquakes and tsunamis. Then the two bodies would combining their masses. This would make Neptune nearly 17% larger and more massive. It would also alter the planet's orbit and its gravitational interactions with other bodies in the solar system, perhaps throwing the orbit of other objects into chaos. Additionally, the composition of Neptune would change, incorporating materials from Triton's interior. While Triton's exact composition is unknown, it is thought to contain water, nitrogen, methane, and other volatile compounds. These substances would mix with Neptune's existing atmosphere, potentially altering its chemical properties and behavior. It's also likely that the impact would generate a large number of new moons, as debris from Neptune and Triton would scatter across the planet's orbit. Over time, this debris could coalesce into new moons, potentially forming a ring or swarm around Neptune. These new moons would likely be small, ranging from miles to hundreds of miles in size. They might also be irregularly shaped due to the chaotic conditions that existed at the time of the impact. After the dust settled, Neptune would be a changed planet. Its atmosphere and orbit would be altered, and it would have new moons. The planet's surface would also be changed as the impact would have reshaped it. New mountains and valleys would likely have formed, and the rings that once adorned Neptune would be no more. Some scientists even believe that such a collision could explain the unusual tilt of Neptune's axis. Currently, Neptune is on its side relative to the Sun, with its poles only about 28 degrees from the perpendicular. This tilt is unusual compared to other planets in the solar system, which are mostly upright. One hypothesis suggests that a large moon, possibly Triton, was captured by Neptune after it had already formed. The impact of the moon on Neptune would have knocked the planet over. This would explain the unusual tilt and the fact that Neptune rotates almost perfectly on its side. While capturing another body isn't something that Neptune could easily do today, scientists think it's quite plausible that the young Neptune could have done it. A young Neptune would have been significantly more massive than it is today. It would have been hot, gaseous, and rapidly rotating, making it easier to capture a large body like Triton. Today, however, Neptune and Triton have settled into a stable orbit that works well for both of them. Triton's gravity helps to stabilize Neptune's atmosphere and rings, while Neptune's gravity keeps Triton from escaping the solar system. It's likely that this will continue to be the case for millions or even billions of years, and astronomers will continue to study their unusual relationship to learn more about the formation and evolution of the solar system. Let us know in the comments below if you enjoyed this video. Thanks for watching.